Hi everyone, I am Santi from Department of Mathematics and Statistics, Bhavan Vivekananda College. I am here with my lesson 14 of linear algebra on vector spaces. In this lesson, I am going to explain these three concepts, that is finite dimensional vector spaces, and the second one, dimension of a vector space and subspace. The third one, problems on finding dimension of a subspace. So let us see first what is finite dimensional vector space. If a vector space V is spanned by a finite set, then V is said to be a finite dimensional vector space. Actually, these finite dimensional vector spaces, all these we have been dealing with in all our previous lessons. So let us see first example. Suppose if I consider R3, then what is its standard basis? S is equal to 1 0 0 0 1 0 0 0 1 set containing unit vectors. Then we have R3 is spanned by S, because we know since this is a basis of R3, it will be spanning R3. That is, every vector in R3 can be written as a linear combination of these vectors. Then this much is enough. Since R3 is getting spanned by a finite set, then you will call R3 as a finite dimensional vector space. Let us read again this line. If a vector space V is spanned by a finite set, then V is said to be a finite dimensional vector space. Now, let us see, can you tell what is R3? Is it finite? Is it having finite number of vectors? No. R3 will have infinitely many vectors, but it can be spanned by a finite number of vectors. These three vectors can make linear combinations of these three vectors will give you infinitely many vectors in R3. That means though this vector space R3 is having infinitely many vectors, it can be spanned by a finite set. Then such a vector space, we call it as a finite dimensional vector space. So finite dimensional doesn't mean that it has finite number of vectors. It means that it can be spanned by finite number of vectors. For example, if you see in vector calculus, you have learned about each vector, how is each vector denoted by in a vector space. Suppose for example, let me write some vector 2i plus 3j plus k. So any vector, this is in the geometry, or you can say vector calculus. So where is this? You have there in the system I, j, k are unit vectors among the coordinate axis. Then any vector in this three-dimensional space, you can write it as a linear combination of I, j, k. 2, that is C. 2i plus 3j plus k. One more vector I will write I minus j plus k. Or I will write another vector 3i plus 4j plus 5k. So what are all these? These are all linear combinations of ijk only. That means the finite set of vectors ijk. You can say these ijk are nothing but I is unit vector 1 0 0 point among x-axis, j is 0 1 0 among y-axis, k is 0 0 1 with coordinates among z-axis. They are nothing but this only. So the entire three-dimensional space here is spanned by just three vectors. So there are infinitely many vectors in this space, but they are spanned by a finite set, that is ijk. That is what we mean by finite dimensional vector space. So similarly, if I talk about hence R3 is finite dimensional. So if I say R2, what is it? It's finite dimensional because it is spanned by R2 is spanned by unit vectors 1 0 0 1 or any other basis. R2 also has many bases. Like R4. R4 also has many bases. Standard ordered basis is 1 0 0 0, 0 1 0 0, 0 0 1 0, 0 0 0 1, and many other bases. Like that, all these are finite dimensional vector spaces. Similarly, P1, P2, and so on, Pn. So what is P1? P1 is spanned by this, we know, we have seen when we were talking about basis 1 comma t. That means, what do you mean by that? P1 has infinitely many polynomials, but it can be spanned by two vectors, 1 and t. That's why we call P1 also as a finite dimensional vector space. Similarly, P2. P2 is spanned by set containing 1 t square. All vectors in P2 are spanned by these three vectors. So we'll say that this P2 is also finite dimensional vector space. Like that, all these P1, P2 and so on, Pn, they are all finite dimensional vector spaces. So next let us see then what is dimension of a vector space. The number of elements in any basis of a finite dimensional vector space V is called its dimension. Now just we have defined what is a finite dimensional vector space, and you have seen here, for example, for R3. What is the basis of R3? S is equal to 1 0 0 0 1 0 0 0 1. It is spanned by three vectors, and this is a basis. How many vectors? 3. So where S has 3 elements, that means dimension R3 is equal to 3. So similarly, if you take this standard ordered basis of R2, 1 0 0 1, then how many vectors in the standard ordered basis? 2 vectors. So dimension R2 is equal to 2. And see, if it is dimension R2 is equal to 2, it means that every other basis of R2 will contain exactly 2 vectors, because R2 will not just have only this as basis, it will have so many other bases, but all those bases will have same number of 2 vectors since its dimension is 2. This will prove it later as a theorem. So similarly, dimension R3 is 3, dimension R4 is 4, and so on, dimension Rn is n. And similarly for P1, the one set containing 1t is a basis, standard basis of P1, hence dimension P1 is equal to 2. So any other basis of P1 also will have 2 vectors. Similarly, dimension P2 is 3, dimension P3 is 4, dimension Pn is n plus 1. See here, dimension Rn is n, but dimension Pn is n plus 1. Remember this point. Now some more important points. Let us go through this. First point, the dimension of the zero space. What is a zero space? It has only a zero vector. If it has only a zero vector, how many vectors will be in the basis? In the basis there won't be any vectors, because zero vector is not considered for basis. That's why what is the dimension of zero space is 0. And if a vector space V cannot be spanned by any finite set of vectors, then it is called as infinite dimensional vector space. Any vector space, if it cannot be spanned by a finite set, then we call that vector space as an infinite dimensional vector space. And the third point, all the bases of a vector space must contain the same number of vectors. So if any vector space has a basis, not one basis, it will have so many bases, all those bases will have same number of vectors. Now let us see the dimension of subspace. So as we defined dimension of vector space, the same way it goes with dimension of subspace. The number of elements in any basis of a subspace H of a vector space V is called its dimension. So basically we can remember dimension of either a vector space or subspace as the number of elements in its basis. And here one point we have to remember, a subspace of a finite dimensional vector space is also finite dimensional, right? That means since the main vector space is finite dimensional, all its subspaces will be also finite dimensional vector spaces. Now we'll go through some problems on finding dimension of a subspace. Then why are we not trying to find dimension of vector spaces? we have seen the standard vector spaces, right? R2, R3, R4 and so on, Rn. Their dimensions are clearly, it is standard. They are seen. R2 dimension is 2, R3 dimension is 3. Whereas P1, P2, P3 and so on. P1 dimension is 2, P3 dimension is 4. There nothing you have to find out dimension of vector space. So only we'll have to find out dimension of subspaces, because all subspaces need not have the same dimension as the vector space. So first we'll work out the problems on finding dimension of subspace. Later we'll discuss about the theory points. Find the dimension of the subspace. H is equal to set containing a vector of the form a minus 3b plus 6c 5a plus 4d b minus 2c minus d 5d such that a, b, c, d are in R. What do we mean by dimension of the subspace? Dimension of subspace is equal to number of vectors in its basis. So first of all we have to find the basis, find a basis for the subspace, and then we have to find the number of vectors, that is just counting how many vectors forming the basis. So first of all we have to find the basis. So for this, so let me take H is equal to, now how can I write this H as, see here H is defined by this vector, it is generated by this vector. In this vector you have A, B, C, D, 4 parameters. So I can write it as A into, so what is the coefficient of A? 1, 5, 0, 0, plus next I have second parameter is B. So what are the coefficients? Minus 3b coefficient, and here it is 0 and here it is 1 and 0, and then plus c into 6 0 minus 2 0 plus d into, so 0 4 minus 1 5. So this single vector in this H is can be written like this as a linear combination of 4 vectors such that A, B, C, D belong to R. So let me write here such that, so let me use the words A, B, C, D belong to R. They are real numbers. So this is H for us. What do you mean by this? Implies H is equal to span of these 4 vectors. If I take this one as V1, V2, V3, V4, so H is span of V1, V2, V3, V4. So now how do we check whether, not checking, just how do we obtain a basis for this from the span of these vectors. So now our task is to obtain the basis for H from the set V1, V2, V3, V4. For this we have the previous problem's procedures using spanning set theorem. So let us use spanning set theorem. So for that I will take, let A is equal to a matrix which has these vectors V1, V2, V3, V4. What are V1, V2, V3, V4? V1 is 1, 5, 0, 0, and V2 is minus 3, 0, 1, 0. V3 is 6, 0, minus 2, 0, and V4 is 0, 4, minus 1, 5. So now I have this matrix. I have to reduce it to echelon form. So reduce it to echelon form. So what are the operations? First let us mark this pivot position. Then using this column we have to make zeros. So what is operation? Only in R2 I have a non-zero element. This R3, R4 they are already 0. So only R2 I have to change in the first step, that is, so 5 is there, 5 minus 5 will be 0. So R2 minus 5 R1. Only this is the transformation I will apply. So I will get this matrix is transformed to, so I have 1 minus 3 6 0, and then 5 minus 5 0, and then 0 minus 5 into minus 3. So minus 5 into minus 3 is 15, so it is 15, and then 0 minus 5 into 0 minus 5 into 6, 0 minus 30. So this is minus 30, and then 4 minus anything here, this is 0 only, so I'll get 4. It is 0 1 minus 2 minus 1, 0 0 0 5. So let us check again pivot positions. This is pivot here, and this is pivot second row, and here now I have to make this 1 0. So my next transformation is for R3. So for R3, what do we do here? For R3 you have to make this 1 0. So R3, so I will multiply R3 with 15. 15 times R3, 15 into 1, 15 minus R2. So this will give me 1 minus 3, 6, 0, and then 0, 15 minus 30 and 4. Next is 0. Now 15 into 1 is 15 minus 15, 0. So this is 0. Then 15 into minus 2 is minus 30, and then minus 30 minus of minus 30, minus 30 plus 30, which will give you 0. 15 times R3 minus 30, and then minus of minus, then it will be 0. So I have here, next one will be minus 1. So 15 times minus 1 is minus 15, and minus 4 minus 19. And the last row there is no change. Now let us mark again pivot positions. This is 1, and here it is 15, and the next I have here is minus 19. Now, and even the last row, this I have to now make it 0, but already this I can easily make it 0. Before that also we can decide, so but still let us make it 0. So what do I do for that is, for R4, so multiply this with 19 times R4, and then plus R3, not plus R3, 5 times R3. So 19 into 5, and then plus minus 19 into 5, so which will be 0. So this will be reduced to the matrix. Here 1 minus 3 6 0, and then 0 15 minus 30, and then 4 0 0 0 minus 19, and then 0 0 0 0. Now I think we have come to echelon form. Second row this is pivot position, and third row this is pivot position. So here now what are for our pivot columns now? So this is a pivot column. So C1 is a pivot column. This is a pivot column. C2 is a pivot column. This is not a pivot column. So this will be C4 again. It will be pivot column. So C3 is not a pivot column. Now this is reduced to echelon form. So our next task from this is to get a basis for H. So now how many columns you have? 4 columns. So I will take here which columns are pivot columns, C1, C2, C4. So here I will write C1, C2, C4 are pivot columns. So implies I can say here set containing V1, V2, V4, the corresponding vectors in the given set forms a basis for H. That is set containing what are the vectors from the set A not from the echelon form, that is 1, 5, 0, 0. V1 the first vector and the second vector minus 3, 0, 1, 0, and the third vector 0, 4, minus 1, 5 forms a basis for H. And something else is asked in this dimension actually, that is dimension of H, that is equal to dimension H is nothing but number of vectors in any basis, that is equal to 3. Hence dimension of H is 3. Here are few more problems for your practice. So first one, H is given as set containing vector of the form p plus 2q minus p, 3p minus q, p plus q, such that p comma q belong to R. Then find the dimension of H. Next one also in the same way, find the dimension of this subspace which is spanned in this way. And the third one, find the dimension of the subspace spanned by these vectors. Our next example is find a basis for the subspace H is equal to set containing the vector ABC such that A minus 3B plus C is equal to 0, B minus 2C is equal to 0, 2B minus C is equal to 0. Also find dimension H. In this problem, we are given here that H is spanned by a vector. What is that vector? ABC is given. That is, it is spanned by ABC. But what are those ABC? They are satisfying some equations. A minus 3B plus C 0. B minus 2C is equal to 0. And 2B minus C is equal to 0. So you need to find the basis means first of all you need to know how many vectors are there in the basis, how to obtain those. Each vector in H is in the form of ABC where ABC are satisfying these conditions. So first what do we have to do here is to find H, to find basis for H. First we need to find values for A comma B comma C, because that A comma B, A, B, C is the vector which is spanning H. That means we have to solve, that is to solve the equations A minus 3B plus C 0, B minus 2C 0 and 2B minus C 0. So you need to solve this system of equations. How do we solve this system of equations? Again, we'll use this echelon forms of matrix. So I'll consider the augmented matrix. Consider augmented matrix AD. So what is that augmented matrix AD? So this will be 1 minus 3 and 1 0, and A coefficient is 0 and 1 minus 2 0, and then A is not there 0, and then 2 minus 1 0. So you need to write the augmented matrix and you have to reduce it to echelon form. So you have to reduce this to echelon form. So what are you are going to mark the pivot positions. This is the pivot position here, and already this column you have to make 0. These are already zeros. So second row pivot position is 1, and then you have to make this 2 0. So I'll apply the transformation here for R3 minus 2 R2. So this matrix is transformed to, so 1 minus 3 1 0, and then 0 1 minus 2 0, and then 0 2 minus 2 will be 0, R3 minus 2 R2, and minus 1 minus 2 into minus 2 is 4, minus 1 plus 4 is 3, and then 0 minus this is. Now again let us mark the pivot positions. This is pivot here. So I have, this is pivot here, and this is pivot for me. And this column we have, because it is augmented matrix, we don't consider this. If we are not taking augmented matrix only the vectors, then we will not have this, we'll consider this last column also. But here you have taken this, so I have C1, C2, C3, all are pivot columns. All are pivot columns. C1, C2, C3 are pivot columns, implies I will write here all the three columns are pivot columns. So what are the three variables in this? A, B, C are basic variables. Then is there any free variable? No free variable. If there is no free variable, that implies unique solution. And this is a homogeneous system of equations. Here you can check. So unique solution means only zero solution, or you can just even rewrite the equations. This 1 implies, I can say 1 implies, I will rewrite the equations, a minus 3b plus c is equal to 0, then b minus 2c is equal to 0, and 3c is equal to 0. Now 3c is equal to 0 implies c is equal to 0. Then substitute in b minus 2c is equal to 0, which implies you will get b minus 2 into 0 is equal to 0. That implies b is also equal to 0. Then if you substitute in first equation, that is a minus 3b plus c is equal to 0, you will get a minus 3 into 0 plus 0 is equal to 0, which implies a is also 0. Now we got a is equal to 0, b is equal to 0, c is equal to 0, and our h is spanned by the vector abc. That implies it is spanned by 0 vector. That is, you can even say it is like this, any one of the way. Then how many vectors are there in H? So 0 vector will never be counted for the dimension. Hence, dimension H is equal to 1. That is, I can say, since 0 vector is not counted in basis. So it is not 1, sorry, this is 0. Dimension h is equal to 0. Now let us look at this problem. Find the basis and dimension for the subspace h is equal to set containing element of the form a, b, c, d such that a minus 3b plus c is equal to 0. Earlier you have done a problem. So when h is equal to set containing a, b, c, where these a, b, c are given with some conditions. But here what is it given? So let me write once. H is given as set containing a column vector a, b, c, d. The same ordered 4 tuple I am writing it as a column vector such that a minus 3b plus c is equal to 0. And here you are having 4 variables a, b, c, d, but you have information only about a, b, c. You have only one equation here. So what do we have to do here? You have to find a, b, c, d such that a minus 3b plus c is equal to 0, and you don't know about d, so d is equal to d. Implies I will write like this the equations. I have 2 equations, but here I have 3 variables, so let me write a minus 3b plus c is equal to 0 implies, let me write it as a is equal to 3b minus c, and this is 1, and d is equal to d. Therefore, what will be h for me? H I will write like this. A is 3b minus c. And b you are not writing again. So writing b in terms of a is meaningless. So I am keeping b as it is. C also again writing in terms of a and b is also meaningless. So keep it c as it is and d as it is. Such that a, b, c, d are in R. So the same, this equation, whatever is given, we have little bit changed it and modified it. We reduced one variable here. Now you got, here a is not there. So let us remove this a. B, C, D belong to R. So now our task is to find out B, C, D. So our task is to find B, C, D. So let us write this H as then. So how many parameters? I have 3 parameters B, C, D. So if I take B, 3, 1, 0, 0 plus C into minus 1, 0, 1, 0 plus D into 0, 0, 0, 1. Such that you can say here A, B, C, D belong to R. So what do you mean by this? You have a set of vectors here. So it is given that H is equal to span of set containing 3, 1, 0, 0 minus 1, 0, 1, 0 and 0, 0, 0, 1. So from the given condition, given equation, H is a set of some A, B, C, D, we have obtained another one that H is span of 3 vectors. Now how do we solve it? We have the previous methods, like taking these 3 in the matrix and then reducing to echelon form. That method we will be following. So now to obtain the basis for H, we'll use this matrix method. We'll consider matrix with these 3 vectors as columns, that is 3, 1, 0, 0, minus 1, 0, 1, 0 and then 0 0 0 1, and then we will find out how to reduce it to echelon form. Reduce to echelon form. See, we can add here last zeros, or we don't add zeros, it will be the same. If you are just doing directly LILD problem, then use 0 zeros. Now here you need not use those 0 zeros. You can just avoid them. Now let us mark, this is the pivot position. So I have to make these, this is already 2 zeros are there, this one I have to make 0. So what do I apply? The transformation for R2, 3 times R2 minus R1. So this will be transformed to, so 3 minus 1 0 0, and then 3 times 0 minus R1 will give you 1, and then this will be anyway 0, and these you are not changing anything, 0 0 1. Now again let us mark the pivot positions. This is pivot and this is pivot. So using this, now you have to make this as 0. So what is the next transformation we'll be using? You have to do for R3, R3 minus R2. So this will be transformed as 3 minus 1 0 0 0, sorry, 0 1 0, and then 0 1 minus 1 0 0, and there is no need to change anything here, 0 0 1. So now again mark pivot positions. This is pivot and this is pivot, and here this is 0 row, we must send it to the next. So our next transformation is R3 to R4. So this we will get it as 3 minus 1 0 0 1 0, and then 0 0 1, and then 0 0 0. So now what are the pivot positions? Pivot positions are this one and this and this, and here all these 3 columns, because 3 variables you have BCD. If I use, see, remember, if I use here augmented like 0 0 0 0 also, then I will omit the last column, but I haven't used this, so I can consider all these 3. So these all C1, C2, C3 are pivot columns. So if C1, C2, C3 are pivot columns, so what do we write here? Implies C1, C2, C3 are pivot columns. That implies, what are the 3 variables you have? B, C, D. B, C, D. Or here we don't need to write variables. We just have to mention whichever are the pivot columns, they will be Li. C1, C2, C3 are pivot columns, which implies I can say the 3 columns. What are those? V1, V2, V3. We haven't all the 3. That is the 3 vectors. 3 1 0 0, minus 1 0 1 0, and then 0 0 0 1 are linearly independent. If they are linearly independent, implies set containing 3 1 0 0, minus 1 0 1 0, 0 0 0 1 is basis for H. And what will be the dimension then? Therefore, dimension of H is equal to number of vectors in basis, that is equal to 3.